Assalamualaikum dear viewers, Shoaib Ahmed is here with the new lecture of the electrical engineering, and today is the topic is the reactor control of the short circuit current. Now there are the two types of the reactor in the power system, the current limiting reactors, okay, to limit the short circuit current, and the second one is the shunt reactor to compensate the reactive power. They are used for the reactive power compensation. Okay. Now in this lecture we are going to discuss the current limiting reactors. Okay, what is the purpose of the reactors that are used in our power system? So the circuit breakers are connected in the power system must be capable of dealing with the maximum possible short circuit currents that can occur at their point of connection. So circuit breaker can also interrupt the faults under the all conditions in the power system. Maybe in the normal operating condition it can be remotely turned off, or it can remotely shut down the system, or it can automatically interrupt the fault whenever the fault is occur. So it can be operated under all the condition, but generally the reactance of the system under the fault condition is very low and the fault currents are dangerously high. In the previous video of the short circuit, I have described the short circuit at the point of the fault. At the point of the fault, that current is very high, dangerously high, and the impedance of the system is very low, and the voltage at the fault point is reduced to the zero. So the reactance of the system is very low because reactance and the current both have the inversely proportional. Okay, so if the X is very low, so current is dangerously high. So in order to limit this short circuit current, if there is a fault is occur in the power system, so current is very dangerously high. So now this current is to be limited to a very low value, so that it can handle. Okay, so additional reactants that we are using that are called as the reactors are connected in series with the system to at a suitable point. So in order to limit the short circuit current, so that can be produced due to the any reason or any fault which is occur in the system, so that current can be easily limited by, or short circuit current can easily be limited by the reactors that are connected in series with the power system with the particular equipment. Okay, and then that reactor is to provide the additional reactance to the particular equipment in order to limit that short circuit current. Whenever a fault is occur, the short circuit current is very dangerously high because the impedance of the system is very low at the fault point. Now a reactor is a coil having the number of the turns of the wire designed to have a large inductance in comparison to that their ohmic resistance. So reactor is a coil and it has the large inductance, and it in comparison to that ohmic resistance or the resistance. Now what are the advantages of the reactors, current limiting reactors in the power system? So first advantage is that reactors limit the flow of the short circuit current and thus protect the equipment from overheating as well as from the failure due to the destructive mechanical forces. So reactors are capable to withstand the short circuit currents and obviously to protect the equipment whenever a short circuit is occur, or it can protect the equipment from the overloading, because in the overloading condition the rated current of any equipment is beyond that its rated current. So what happened, so it may deteriorate the insulation of that equipment, or it may damage the it can damage the particular equipment. Okay, and second one is that troubles are localized or isolated at the point of the where the fault is generated without communicating their disturbances effect and to the other parts of the power system. For example, if the fault is occur at this point, at the generator point, now at the point of the fault is limited by the reactor which are connected with this generator. Okay, so now that point of the fault is to be localized, or that short circuit current at the generator side is to be limited by its reactor which is connected in series with that particular equipment, so without affecting disturb to the other electrical your power system equipments which are connected with the same bus bar. So the faults are to be localized or isolated at the point where they originate without communicating or disturbing the effects to the parts of the power system. Okay. Now they permit installation of the circuit breaker of the lower rating. Obviously these reactors are provide the additional reactance to the system, so the circuit breaker the rating is very low because of the presence of the reactor in the power system. So now we are coming towards the location of the reactors. So the short circuit current limiting reactors may be connected always, the short circuit current limiting reactors are always connected in series with the generator, they are connected in series with the feeder, and they are connected in series with the bus bars. So now coming towards the generator reactors, so when reactors are connected in series with the generator, so they are called as the generator reactors. As you can see this diagram, consider these are the three generators G1, G2 and the G3, and each generator has its own reactor that connected in series, okay, and this is the main bus bar. Generators are supplying the voltage or the power to that main bus bar, and the feeders are connected with the main bus bar. So here what are the generator reactors? The reactors which are connected in series with the generator, so it provide additional leakage reactance, reactance to the generator to limit the short circuit current. So this is called as the generator reactor. So reactor may be considered as the part of the leakage reactance of the generator. Okay. Reactors are used to protect the generator in the case of any short circuit beyond the reactors. Okay. So if the fault is occur on the generator side, so this reactor, particular reactor that is connected in series with the generator, it provides the additional reactance to limit the short circuit current. So so this is the main beauty of the reactor, to limit that short circuit current, because whenever a fault is occur on the generator side, so that it can withstand the short circuit currents or enormous currents. So what are the disadvantages of this system? There is a constant voltage drop and the power loss in the reactors even during normal operating conditions. Obviously the presence of the reactance with the machine, so continuously power loss and the voltage drop that may be occur under the normal operating conditions, because due to the presence of the reactors, and these reactors are provide the additional reactance, and reactance is obviously obviously it can consider to be the part of the leakage drops and the power loss in the system. So second is that if the bus bar or the feeder fault occurs close to the bus bar, okay, the voltage at the bus bar is very low, thereby causing the generator the loss of synchronism or the fall out of step. For example, if the fault occur at this point at the bus bar, now reactors are connected in series with the generator to limit the short circuit current at the generator side. Now there are no any additional reactances are connected in series with the feeders and also the bus bar. So for example, if the fault occur at the bus bar, now what happened? The voltage at the bus bar is very low, because whenever a fault occur, the current is very high, voltage is reduced to the zero. So if the generators are connected in parallel across this bus bar, obviously the terminal voltage of the system will be affected and generators may lose the synchronism. Okay. If the fault occurs on any feeder, the continuity of the supply to the other is likely to be affected. For example, if the fault occur on any feeder, for example, here the fault occur, okay, now because there is no any additional reactors are connected in the in series with the feeders or the bus bar, so at the fault point obviously this will affect the bus bar voltage and the whole bus bar will be affected due to the faulty condition. So these were the disadvantages of the generator reactors. So modern power system generators have sufficiently large reactance to limit the short circuit current. So this was the lecture regarding the reactor. So if I am going to summarize the lecture, so what is the function of the current limiting reactor in the power system? It is used to limit the short circuit current, and it is always connected in series with the equipment which is to be protected. Okay. So what are the advantages we have discussed of that current limiting reactors, and generator reactors we have discussed in today's lecture. So that whenever the reactors are connected in series with the particular generator, so that it can limit the short circuit current if the fault is occur on the generator side. So it considered as to be the leakage reactance of the generator. So if we are connecting this reactors in series with the particular generator, so that we can limit the short circuit current, so that which are produced due to the fault which may occur in the machine side. So this was the lecture, and I hope that you have enjoyed today's lecture, and please at the last subscribe my YouTube channel, like my videos, and thank you very much for your motivation.